Very excited to welcome Yakuhito to FOMO. Yak's been on the show before, but what I realized is we hadn't done a developer spotlight the same way that we had done this with Acevale and a few of the other developers. So this was not due to our oversight, but rather that Yak's been on here talking to us so many times that it just didn't seem obvious. But I felt like we should do the let's give him the Chia developer spotlight graphic and whatever. But anyway, Yak, welcome to FOMO. We've got quite a bit to talk about. At least to start, I wanted to start with talking about what you did with CircuitDAO. This was phenomenal. We've been watching CircuitDAO for so long and hopeful and excited for them to get launched. And when they finally decided that they were going to do this last thing where they wanted to validate their puzzles, they were pretty confident that nothing was going to be found. And then you come in here and you swung hard and you found three Sev ones, or tell us a little bit about what's going on there.
Thank you for having me. So the story is that CircuitDAO previously had an audit from what I would call a tier one security firm. So that's Zelig, and they are very well known in the crypto space as being one of the top auditors. Then they had kind of a private Immunify competition, so that's kind of a second audit. And then they just opened it up to everyone and said, we're going to run a kind of bug bounty for 1 month. And during this period, everyone can submit reports. And then there's a guaranteed prize pool that will be distributed according to what kind of vulnerabilities you find and how unique they are. So this last competition turned out to have, it found, I think, 5 critical vulnerabilities, uh, a high one, and a bunch of mediums. I was the only one to find 3 criticals out of that overall result.
So, and when you started looking at it, really what you focused in on was some of the input validation that was happening with it, because they have an extensive set of puzzles. Would you say that CircuitDAO has one of the most sophisticated pieces of Chialisp that exists out there? It seems that it is pretty sophisticated, but I guess I'm interested to hear your take on it. If you think, are they top five? Are they number one? Or where are they? And like, tell us a little bit about how you approached looking for vulnerabilities within their Chialisp.
Yeah, maybe. Would it be better if we started with a short intro on CircuitDAO and what they do?
I mean, we sure just we've covered it like extensively, but yeah, we should. Why not? Just for the sake of completeness. Yeah, let's do it. Give us a 1-2 on Byte Cache.
Yeah, so basically, in the real world, there's a technique where rich people usually avoid taxes by borrowing money against their stocks. And what MakerDAO really did, which CircuitDAO is pretty much modeled after MakerDAO, is give that to ordinary people on the blockchain. So the idea is that you lock, say, $100 worth of XCH, and then the protocol gives you a loan for, let's call it $50. The whole idea is that the stablecoin, be it DAI or Circuit's BYC Byte Cash, is worth $1 and it's always over collateralized. So if the value of your collateral, which is XCH, reaches, let's say, 70, your position will be liquidated. So someone will have the power to buy it. You'll receive a small penalty for being liquidated. Um, but then BYC maintains its $1 peg. And a lot of the complexity around these protocols comes just from managing this, managing deposits, liquidations. Uh, because they charge interest, they also need they also saw the opportunity to kind of redirect some of that income to the earn you see on the right. So the way it works, Circuit takes a cut, but then the rest of it is redirected to BYC holders that stake their BYC. Essentially, they earn a portion of protocol revenue for holding BYC. And that's what kind of generates enough demand for BYC for it to maintain a $1 peg.
And so this is a traditional model where essentially what's happening is borrowers are paying a certain rate, and then people who have the assets are earning a yield, and then there's a spread in between, and Circuit is making money on that spread. This is how traditional lending in banks was supposed to work is, they made money because they put their money to work. They lent it out to somebody, and then the people who had the money and actually deposited it, then they got some yield, and the borrower got to borrow, and everybody was kind of happy. And then things kind of fell apart with the whole Federal Reserve and banking and whatever. But this brings some sanity and some ability to do borrowing. So the yield really comes from the borrower who's paying an interest rate.
Exactly. When you know where the yield comes from, and the spread that CircuitDAO makes, it can also be considered as kind of an insurance when liquidations fail, when the price drops so quickly that maybe they borrowed $50 worth of BYC, but you can only liquidate the vault for 40. Then it's expected that the protocol would step in and cover that position. And also, what CircuitDAO had to also cover is having an oracle that reports XCH prices. Uh, they do that by having a set of people, a set of announcers that have different price feeds they announce on chain, and then the oracle, consuming all those price feeds, has an algorithm that mainly takes the median uh, and then waits an hour. But then sometimes during flash price crashes, it will update the price more quickly. So uh, they did a great job making CircuitDAO looking like it's pretty simple, but it in the background it's actually a pretty complicated protocol that tries to automate away most of the stuff that needs to be done quickly to keep the protocol working.
Okay, so this is the infrastructure, and one of the ways that the entire thing works is there has to be a steady stream of price information that's flowing onto the chain. This is done via the oracles, and I think that's one of the places where you found a problem was through one of the oracles. So an oracle is a general purpose mechanism where if you want to have information about the outside world in a blockchain, you have to do coin spends to get that data into the chain and make it operable so your protocol or whatever has access to that data. So this Oracle is a very important type of facility. Lots of different places within the world of blockchain use this general purpose facility, and the Oracle that exists for Bytecash for CircuitDAO is essentially currying in the price of Chia on a regular basis so that the protocol can know if the price of Chia is rising or falling, and what should be done about liquidation.
Yeah, exactly. The oracle is the source of truth. And where I found the vulnerability, it was actually the upstream announcer. So that's one of the price feeds the oracle consumes. So CircuitDAO is made to be dynamic. That's what you need for this kind of system, really, because there's liquidations, there's changing price, and having a dynamic set of price feeds is a very good decision from that point of view. People, some fees will become unavailable. As the protocol grows, you might want to take in more price feeds or change existing ones for more secure ones. Or if say Chainlinks comes on Chia, then you want Chainlink to be one of the price feeds because they are very trusted and well regarded. So what I found um, in in the price feed mechanism was a vulnerability that would allow anyone to appear as an approved price feed. Um, that basically means that I, an attacker, might be able to self-approve their own price feed to be considered by the oracle, which would be very bad because if the attacker does that a bunch of times, then their price feeds become the majority. So the oracle will produce a very wrong price potentially. I'm not sure how in depth you want me to go.
I think the thing that is interesting in this is, do you feel like the some of the vulnerabilities that you found within the Chia list, are these things that were very specific to CircuitDAO, or are we advancing the state of the art of Chialist programming? Because I know at least one of the things you found was an input validation thing, which seemed to be very similar to one of the original problems that we had with Cat 1 and why we had to go from Cat 1 to Cat 2, because there was an input validation problem there, and through a way of manipulating how it interpreted one of the parameters, that you could make the program do something it wasn't intended to do. Did I get that right? Is that the general sense of there were some input validation problems Zelic missed, that the CircuitDAO team missed, that you kind of focused in on that? Or are there any parts of this where you feel the state of the art of Chialisp has significantly advanced? Because I felt like one of the bugs that you found, you were talking about that there was a general applicability to anybody who's writing Chialisp.
Yeah, well, 2 points there. Um, the bugs are more, I think they're more CircuitDAO specific, probably because Zelig covered all the best practices in their audit. Uh, there was another critical one of an unsecured input parameter, which was found during both the Zelig audit and then the competition, because the fix was lost in merges on CircuitDAO side. But mostly, I would say these were fine logic bugs, things that are very easy to miss. Uh, on the other hand, I also feel Chialisp has a long way to go, especially when it comes to type assertions, um, and also unsecured solutions. Because for most of Chia's life, the apps that were being developed, they were not decentralized apps. They were kind of advanced custody, which we are also seeing now with CNI. They're literally calling them vaults, and it's advanced custody. But also offers and so on, they concentrated on a P2P aspect where a user would interact with a user. That's no longer true when you're thinking of, say, TibetSwap or the bridge or CircuitDAO. There, the user is interacting with a protocol, and there is a different set of assumptions. So, for example, if you're interacting with a protocol, you need a nice way to assert that what you're doing is what's happening, because otherwise, someone could see your transaction in the mempool and modify it. Um, but Chializ really lacks a way to assert that in an easy way. So dApps now have to implement kind of a workaround, which I also recommended to CircuitDAO, but I'm also doing in the stuff I'm working on, where they create an announcement of what's happening so the user can assert it.
Well, and we have this hard fork that's coming up, and I know that there is some thought to what else are we going to jam into the hard fork. Do you feel like this is something that could get hard forked in when we change the plot format consensus? Like, this, when you say workaround, it to me it feels like there's an opportunity here to make Chialist better for the long term. And since we're hard forking and Bram's going to jam in a bunch of stuff anyway, is this one of those opportunities? And do you feel like maybe this is the time when Chialist developers of the world should unite and lobby for this also to be included in the hard fork that's upcoming?
So I've been talking to a few people about that, and there are some conditions that would slightly help, such as asserting that a coin was created. Currently, you can only assert that it's spam, but in some situations, you just want to know that a specific coin was created, or asserting a solution is exactly what you want it to be. But uh, a very big roadblock, which I can't quite get around right now, is that asserting, for example, a singleton's full solution would break scalability, because if you make the singleton really allow multiple people to interact with it in one spend, which is the most cost efficient from a blockchain perspective, um, then you can't assert the full solution because the user might want to later interact with the singleton and they won't be able to. So it's really, I'm not sure if the solution is more conditions or just documenting this information about building decentralized apps. Like, hey, you need to include announcements and the driver code that builds the user spans needed to assert them, um, which would be more on the education side.
Well, there was the fast forward spend that I know was being pushed internally at Chia, and I think we got something that's kind of like that, but we didn't really get fast forward spends. Would fast forward spends have helped this, or is that not an appropriate application of that technology?
Fast forward spends are slightly different, because there's still one user spending the singleton. It's just that when the mempool sees kind of two conflicting spans, it knows, okay, if user A gets his transaction confirmed first and the singleton looks the same, as in has the same state and puzzle, then we can just modify user's B transaction to be valid. A more interesting idea I've been discussing mainly with Brendan would be a private mempool that would know what users want to spend for specific applications. It would be able to produce new spend bundles, and then it would give them to the full node for consideration. It would essentially be a service as I want this spend bundle to be confirmed. This is the fees it's paying. The full node can check it's valid, and then it decides if it's going to construct a block based solely on transactions from the normal mempool, or if it will include that spend bundle and then also some transactions from the normal mempool.
Well, I think that the world of private mempools is where a lot of blockchain technology has to go, especially considering that there are things for which you won't want to make them public in the mempool a priori. That either the spend itself is sensitive or dangerous or not publishable in a way because it didn't have the security it needed. And I know that we, even at Evergreen, we made this mistake where we didn't multi-sig some of those little QR code things that we did. So, if you were to see one of those in the mempool, you could steal it. So these unsecured transactions that need to be constructed by a trusted party, I think, is something that you're going to see in the future. I know that the Bitcoin world is thinking hard about how this stuff might work. And we've even seen where private blocks have been auctioned off. So I wouldn't be at all surprised if this is one of the solutions that certain Chia protocols have to fall back to, because there's just rationale for why a private mempool makes a lot of sense. So is CircuitDAO considering that they might need a private mempool for some of the stuff they're doing, or is this just something you're thinking about generally?
No, they were built to launch with current capabilities, so they could just launch to mainnet, and then a private mempool would be an improvement. Um, what I would like to say on the topic is that, first of all, Chia makes private mempools a bit easier to do because of BLS signatures. So you have a spend bundle, and then you can add a very lightweight spend that's unique to everyone who you're sending the spend bundle to. So if the spend bundle gets included in a block because it's leaked somehow, you can just look at that signature, which is unique to the person you shared it with, and then you can figure out who leaked it. So if they're staking anything, you can penalize them, and the signature is right there on the blockchain, so everyone can see who was the entity that leaked the spend bundle. Then my second thought is that we'll eventually need a system like this, just because the normal mempool is pretty slow. So even if you have a way of building your spans on top of current ones, just the act of propagating a span bundle currently takes a few seconds. Uh, I'm thinking of a future where we need a lot of users to interact in the same second with a singleton, with an app. Uh, so to prepare for that, I think we'll need a kind of private mempool.
Okay, wait. What you just described, I'm not sure I know what you're talking about. Why would multiple users need to interact with the same spend bundle in the same second? What are you thinking about here? Can you tell us? This sounds like alpha.
I mean, there's no alpha. It's just think of a simple Tibet swap pair. If a lot of people want to buy and sell the same token, they'll need to interact with the same singleton. Um, so a private mempool is really just a better service than the pair only accepting spans from the Tibet swap master, which is a centralized service.
Oh, I got you. So what you're thinking about here is doing an upgraded Tibet swap. So like instead of waiting for these spends to propagate through the whole mempool, which is necessarily slow. If a lot of throughput starts happening on Tibet Swap, this private mempool would allow for the real-time interaction of people doing spends, and that way, that building up of the transaction that's eventually going to get committed to the chain is kind of acting in this. I don't know. It's almost like a private exchange of data messaging protocol in some sense, is that you've got these interactions that are happening that almost feel like an L2 or a side chain, but using the mempool kind of protocol to do it until you finally arrive at a spend that has reached a fee infrastructure that nobody really wants to touch anymore. They're like, whatever, I'll wait for the next block.
Well, I think that brings us nicely to what I've been working on lately. I've been thinking about decentralized apps, and one thing they have in common is that they need a state. And I think that's something Ethereum got very right with contracts, is that if people interact with the contract can very easily hold a state. On Chia, we have the equivalent, which is a singleton, but it's tricky to hold a state, to update it, to have multiple users interacting with it. And I think that's a thing I'm trying to improve at the Chialisp level, but it will certainly require applications such as private mempools, which, as you said, is just an exchange of information, and then you get that information to farmers so they can build blocks with the spend bundles resulting from that information.
Well, or you just have a farm with a sufficient size and they're willing to put it into the next block. I suppose this might be one where if you have people who were of sufficient size and knew that they were regularly making blocks. But then I'm wondering if we're broaching the time where consensus might be a problem. So I guess at some point you just need to fall back to, you've got a private mempool, you're exchanging data, and then eventually you just publish some big chunk of something out to the world, and then whoever has the next block makes it. Is that how you're thinking about it? So the private mempool is sort of facilitating a pre-block build, and then you publish something that just looks really big and juicy, so all of the farmers just say, well, definitely I want to include this transaction because there's a lot of fees associated with it.
Yeah, the reason I like private mempool is because it includes the word mempool. So in at least in my train of thought, this would require extra compute. So everyone, not all farmers will probably be able to run a private mempool on their farmer, which makes, if people want to run APIs, maybe uh, maybe farmers farming on Raspberry Pis could point their node to those APIs and fallbacks, but also minor farmers that have maybe a bit more compute resources for farming, they could run a private mempool node, which knows how to parse that information, validate it, sort it, and then directly send the valid piece of information to their full node. So in a way, yes, you'll need uh, low compute farmers would still have a part that's centralized, they would get those spend bundles, but they still validate them and include them in blocks if they want to. But I hope farmers with more compute resources can run a node and kind of maintain a certain decentralization for the Prevo mempool as well.
Yeah, so it's kind of like when you're farming Chia, you have this other place you can go to say, is there some private thing that's being built out there that I might want to consider in the next block? If so, look there additionally. So I'm thinking of that there's this way to query from these private mempools, and maybe there's some mechanism to publish where those are at. And that must be what you're thinking about when you're thinking about how do we build decentralized applications, because this is like another kind of layer that exists out there in decentralized applications. This would be like decentralized APIs. You might have lots of different private mempools that are out there building partial blocks and then wanting to advertise the fact that if a farmer wants to make a block, they might have something that they'd want to include.
Yeah, and on Chia, you have a transaction block every 50 something seconds, let's call that a minute. So with the Chialisp, you can maybe get a 10x improvement, so 10 interactions with the same singleton per block. But the next step to take it, I don't know, 10x or 100x, is really to think about these services and how data quickly gets from the user to the farmers, so they can build that spend bundle and consider it for inclusion, because at the end of the day, farmers will have the final say, and probably what will make them include these custom spend bundles and join the private mempool network in the first place is a bit higher fees.
So what else are you thinking of in the world of decentralized applications? I know that you've said in the past that you were thinking about naming, that you were thinking about cat name registries. Are you still working on that stuff? Can you give us any update on where those things are going? Is any of what you've worked on either with CNI or with CircuitDAO helped inform how you would actually build these systems and facilities?
Well, I will call what I did with CircuitDAO something part of what every Chialisp developer should do, which is when you see a new protocol uh, as big as CircuitDAO, you should look into their code base to see if they have any special tricks or interesting stuff that they do, because then you might be able to integrate that into your own decentralized apps that you're developing or you will develop. So it's just mostly it's just keeping up to date. What That's what the audit was mostly about for me. I certainly didn't expect to find critical vulnerabilities in it. I just wanted to understand it because uh, people will have different ideas, and keeping the very good ones and improving the okay-ish ones is how development will really evolve on the Chia blockchain.
Okay, understood. And I feel you on that. That's one of the reasons why I went and started looking at CircuitDAO. It's also why I was looking at gaming, because I figure if there's one place where some really new and novel concepts might be coming in, it's what Art and Bram are cooking up when they're making their online on-chain gaming. So I completely agree. That's why I keep abreast of new Chialisp that's getting developed, and why I keep focusing on, are we advancing the state of the art of Chialisp programming? Because as we advance the art of that type of programming itself, we're able to make more sophisticated types of programs. But going back to the apps that you're working on, so as far as what we need when we're doing decentralized protocols, we need singletons. This is the equivalent of what in the world of Ethereum is their default smart contract. It's a centralized thing that exists on chain, and anybody that wants to interact with that thing essentially goes through one entity. So in Chia we have singleton coins. That's how Tibet swap works. That's how the bridge works. And so are you thinking about that as being the mechanism for how you want to build the cat name registry and the decentralized naming facilities?
Yeah,
Is that where you're going?
I guess I didn't get to the second part of your previous question. So I think it was last December that I announced I was working on decent, uh, decent, decentralized registries for cats and names. Um, so what happened is when I did that post, I already had a working draft code. What I didn't expect was so much feedback and so much room for improvement, both in terms of specific mechanism design for the apps, but also on the primitives. So since then, I think we've gone through maybe 3 major revisions of the code, and now it's finally in a place where I think I'm very confident in it, and it looks good and efficient. So part of those applications, as well as the rewards distributor for which a chip was just released, is a thing called slots and the action layer, and that's really intended to give singletons the power contracts have on Ethereum. So the action layer basically takes care of the needs most decentralized apps have. So, for example, they need to hold the state and access it. Um, yeah, it's that chip. Um, so they need to hold the state. For example, how much XCH do I control at the moment? How much reserves are in Tibet swap pair? They need to access the state and update it. So every time someone swaps, the reserves in a Tibet swap pair will change. Uh, they also need to allow multiple users to interact with them as efficiently as possible. And it turns out that the mechanism Tibet swap v2 uses, which is one action per spend, and then create a new singleton, and then a user can do an action on that and create a new singleton, that's pretty inefficient. So a nicer way to do it is have one spend, and then you accept a list of actions from multiple users, and then you do them one by one. What else? There's multiple functions. So, for example, in a Tibet swap pair, you can swap, you can add liquidity, or you can remove liquidity, and the user chooses from that set of predefined functions. So, really, what this all led to, as well as my work with proving uniqueness on chain, is chip 50, which is kind of the a requirement for chip 51, the reward distributor, which is a puzzle called the action layer that handles most of that stuff, and slots, which are another kind of keeping state that's less frequently accessed. I'll pause there in case there are any questions.
Well, I was pulling up chip 50, so 1 second on that one.
It's in the
Okay.
same PR.
Yeah. Action layers and slots. Okay, so this is like a kind of a general purpose mechanism, and you're referring to this as a framework. And so this mechanism, are you still using the same singleton outer puzzle that we've been using forever, that we use for plot NFTs and pretty much everything in Chia going back to almost the beginning of time? Does it interact with that, or do we need a new singleton to kind of kick this off?
So it still relies on the singleton outer puzzle, and I'm very split between making another one or not, because, well, um, you could technically do it more efficiently. For example, an app doesn't really need to be multed, but the problem is that when changing, you lose future, fast forward capabilities that would be introduced just for the singleton layer. The bigger problem is that Chia blocks can be compressed, and the singleton outer layer is almost always there. So you save a lot of cost just because NFTs or whatever it is in there, they use the same mod for the singleton layer. So changing it would probably have a much lower execution cost. There's the cost of filtering for melt conditions, uh, wrapping the inner puzzle, but it might end up having a larger overall cost because you're not saving on storage.
And storage really is the bigger consideration in most situations for blockchains that have relatively constrained block sizes, which I would consider Chia to be one of them. Is it
It is.
that we, yeah.
That's the main thing you are optimizing for when you're optimizing puzzles, because for every extra byte of storage, you pay 12,000 cost.
Yeah. So you definitely want things small, compressed as much as possible, want to reference puzzles that already exist. I know that there was also a facility that has been discussed, and I don't think it's been launched, which is that you could actually point back to the original puzzle and just reference to it by hash and not have to reintroduce the same puzzle CLVM every single time. But I don't think that's ever been demonstrated in practice, but I've heard about it several times from Adam Kelly and a couple of other people.
I'm pretty sure it works at the consensus level. It's just that farmers don't do it. Like the normal farmers and normal full nodes don't do it. And I don't think the mempool supports it either. But I might be wrong. I know I'm
I think
pretty
you're right. I don't think
yeah.
it's supported generally like that, but you're right. At the consensus layer, it does, and I'm kind of surprised. But I bet with what Bermuda is doing, they got to be thinking hard that they're actually going to bring that into the code base in Chia 3.0.
Yes,
But I guess
I think
I'm speculating there.
yeah, my prediction is that once we see meaningful traffic on Chia, fees will become a problem, and then direction will shift from uh, the direction will shift from what it currently is to maybe making blocks as efficient as possible. So fitting as many transactions as you can while still supporting Raspberry Pis, which is the minimum device that can follow the chain. I am.
100%. Go ahead.
It would be interesting to see, uh, to have the discussion, of course, after there's fee pressure and uh, throughput, the blockchain throughput becomes a problem. So that means the chain is widely used. It would also be interesting to have a discussion on what can we increase. Can we make the code a bit more efficient and then increase the block size while still supporting Raspberry Pis? If that's not possible, can we increase the block size limit and just have higher requirements for uh, running a node? How would that impact decentralization? That's a discussion I think we'll see once the blockchain becomes when the blockchain becomes more used.
Well, I know that with the Rust code base that's being developed by Chia as well as by the guys over at Druid Garden, that the efficiency of the blockchain is going to be dramatically better than when it was mostly all done through Python. So I think if we're thinking about is there a minimum spec that could support bigger blocks, whatever, I think that that's possible, especially from the experiences we had at Evergreen and running Rust code on a Raspberry Pi and just how hyper efficient that code can be. I think that that was absolutely the right move by both of these teams to sort of go all in on a really, really efficient way to achieve consensus. So if Druid Garden finally gets their full node out, or if Chia meaningfully moves almost all of the code to Rust, I think we're going to be in a situation where that conversation is 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 possible. Like, could we have bigger blocks? Is it possible to process them fast enough? Can we do this efficiently? I also heard from Chia that they're moving to a different database, which I don't know if you know much about that, or if you could tell us anything if you do, why that move is being made, if it's a drive for efficiency or if it's something more to running it at enterprise. I heard that they're using RocksDB or whatever that is. Do you have any inside track on what's going on there?
I am not sure about the reasoning, but I know that the official RPC service CoinSet is running on RocksDB, and it's a way to just scale up and make the database faster. I think, okay, I'll first mention that I'm very excited to see alternative full nodes come out. Um, what I what I wanted to say is that I don't think most people are aware, but we have been increasing the block size has been increasing, maybe without them knowing. So the
Right,
official
because
node had it
there was the artificial clamp of the 50% that was put on blocks long ago.
exactly. So it I think the block size at this point doubled because it was 50%, and I think it recently got removed. So that's something that happened in the past, and as they scale up, they make the database read faster, they make the code that's parsing everything faster. I hope we can see an increased size limit, because the more transactions you can get in a block, the more activity with you can have with the same amount of fees and the same amount of fee pressure.
Well, yeah, this has been a fascinating discussion. I think we're kind of out of time here. I'd love to kind of keep going, but we found that if we go too long, then really good content gets buried and people don't get a chance to hear it, because 40 minutes is kind of as long as we can make the show. So I think we're going to have to call that as much as we can discuss today. There may be more that we want to talk about in the future, so we'll maybe talk after the episode a bit and see if there's more that we want to discuss in a subsequent one. I know that you've got these other two things that you're working on that don't feel like we did it justice, but perhaps when the chips get published, you can come back and tell us all about how you're doing decentralized naming and what the cat registry is going to look like. Because if you've gotten all this feedback and you're pretty close on a chip, it might be best to kind of cover that in detail when those get published, and we'll kind of have a full show just dealing with those two. Anything else you want to say as last words, things that you thought maybe we could have covered but didn't?
No, thank you. I'd just like to point out that we are living in exciting times, right? We are talking about the chain being used and how things will happen after that. We are talking about CircuitDAO coming online after completing audits, and it's a very exciting protocol and development for, I would say, the Chia community as a whole. We talked about future decentralized applications, ones that are being built right now, but also ways to make it easier to build more apps in the future. I think 1 year ago, this episode would have been much more bleak, maybe. But the conversation does make me very hopeful for Chia's future, I guess.
All right. And with that, the hopeful note of Chia's future, we'll see you next time on FOMO.